So, hello, my name is Andrea Mocci. I'm going to talk about minimizing the Python discomfort. So, I'm assuming how many of you know Python? Raise your hand. How many of you like Python? Whoa, I was expecting more than I was asking. How many of you like more Python than Scala? Okay, you're in the right place. So, we work with companies mostly, but also with researchers, in particular with economics. A project that we have involves a lot of natural language processing, so we are forced to use Python. And today I want to show you how to use ScalaPy to perform some natural language processing on Scala 3 GitHub issues with the Spacy Python library. So it's a little detailed. Whoops, sometimes I have problems with the keynote and I see something different. But anyway, what I want to do pretty much is something inspired by this paper that studied the use of implicit in code. This is an amazing paper of empirical programming language research by Heather Miller, Jan Witek, and Philip Krikava, first author. So they studied the use of implicit in code. We want to do something similar, the use of implicits, but in the description of Scala 3 GitHub issues, from the beginning of Dotti to the evolution the last days. So we're going to try to extract all the occurrences of implicit something, and extract all the occurrences of implicit, use it as a noun, which is very weird because in English, implicit is just an adjective. But we're going to see if the way developers actually use it in Scala as a noun actually is going to be found by these kind of models. So I'm going to not search for givens. I'm not going to search for using or extensions, nothing like that, just because I'm expecting these mentions to actually decrease. But we'll see if this is the case or not. If you read the issue, probably you imagine that something strange is happening. So the state-of-art Python library for NLP that we're going to use is Spacy. Supports a lot of languages, more than 75. We work in Switzerland, so whenever we deal with natural language, we deal at least with 3, but not 75, fortunately. It's a very strong library, released initially in 2015, and uses deep learning models, and has also certain parts that can plug with large language models. Anyway, this is the typical pipeline that you have in natural language processing task. And you're going to get some text, and like a compiler, you're going to enrich this text with certain phases and more data. In particular, the first thing is tokenizing, so dividing the text into words, and then typing these tokens, in this case with the part of speech, so if it's a noun, adjective, verb, something like that. And then after that, there can be other stuff, but mainly at a certain point, you're going to try to reconstruct the syntactic structure of the sentence. And this is called dependency parsing. There are others, and I'll show you in particular one, but these are the ones that I'll be focusing on today. So in order to minimize the discomfort of using Python, I'm going to use an amazing library called ScalaPy, and it works for the JVM and in Scala Native. It's a library done actually by researchers at Berkeley, by a PhD student at the time, Shadai Ladad. There are plenty of amazing talks about the internals and how it's been done. I want to focus more on the developer perspective, because if you're curious about the technicalities of how this is actually possible, I want to suggest you directly to the talks of the author that are super clear and actually amazing. There's also something on developer perspective, but not on NLP. So this is what I'm going to do. Okay, so I'm going to learn how to do some basic NLP by minimizing the dependency on Python and maximizing modeling and processing done in Scala. So let's start with some basics. Actually, I'm going to use notebooks. I'm going to use Almond, but I had to hack it a lot in order to make it work with exactly the thing that I want to show you. So I'm going to do some imports. These are actually the importing of ScalaPy, the dependency and the imports. I'm going to go through them. Then I have more other hacky stuff to visualize. And I'm going to read the Scala 3 issues that are actually downloaded with the GitHub tool. This, I'm just going to parse it with the Church. I'm going to get the values. This is not very interesting code. So I have all these issues. And OK, this is like how you load a Python module with ScalaPy. Invoke this module, you get the module. And this is like opens the door to the Python world. So everything is dynamic, so without types. I'll talk about Python types at the end, Python annotation, more than anything. So this call here, prefer underscore GPU, that is actually going to speed up my pipelines, is actually like apply dynamic and an apply dynamic. So here you can actually call any method that, if it exists, is going to be called. So it's going to be delegated to Python and it's going to execute. In fact, if you run it and you see what this method actually returns, it's a Python object, still dynamic, and this is uppercase 2. If you don't like it, you can also convert it to a Boolean with this as that uses a type class to convert it, and now you have a Scala Boolean, pretty much. I'm going to load now the pipeline, the real NLP pipeline with the same thing. And here are two components that are going to do something that I'm going to show you with code, because this is not just natural language. This is natural language that contains code. And so this is a little weird for these models, but we're going to make it work. So let's get an interesting issue. One that contains implicit method, just because I pick it up, is like the first one on this list. And I'm going to show it to you. It's the one that was on the slide, actually. And it's on January 11, and actually compiler is not able to find an implicit instance, so this is something that I want to capture. And if it was defined in different compilation unit, blah, 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 if there exists implicit method returning the same but requires some additional implicit context. So 3 occurrences of these implicit things. Okay, so this is good. This is also render markdown, doesn't really matter. So this is the core. So I take the render body of the issue. I'm going to invoke NLP. So this is like a dot apply in Scala. Do you know what it is if you take a Python object and you kind of invoke it like a function? What kind of method is it called? Call. Underscore underscore call. This is important for later. And I get the sentence, pretty much is the representation that I have, but unfortunately, I had to remove the blocks of code because I don't care about those. But the code inside the sentence are there. Like, for example, I'm leaving actually the backticks because I can separate it from the rest of the text. So let's have a look to a sentence. I'm going to have actually a generator of sentences from the doc object. I'm going to convert it to a list, and then I'm going to convert it to a sequence of PyDynamic in this case. And these are actually the sequence of sentences. I'm going to take the first one, and I'm going to show you what is that Spacy does with tokens, post-tagging, and lemmas. So I'm going to tabulate it to explain it to you. So this is the tokenization step. So pretty much the first sentence compiler is not able to find is actually divided in tokens, and the NLP pipeline has already computed like the lemma, so the word as you find in the dictionary, and the part of speech tags. In this case, this is really some uppercase letter the linguists use that is part of some linguistic modeling. And here you have a nice explanation from Spacy. For example, if you have a look to implicit method, you have an adjective, pretty much, and a noun. And that's what we want to get. There are other things like coordinated conjunction, subordinating conjunction, pronoun and verb, something that you should remember from middle school, as it was for me. I'm going to show you briefly what is another step, like named entity recognition. I collapsed it. So this is a task in NLP that tries to take groups of tokens and puts them all together because they represent some kind of entity. So apart from the code that I hack it up, this recognition of an entity as a piece of code, the model I was using is already recognized in Scala 313 as a product. Maybe not really a software product, but a product, right? This kind of makes sense. And this is strange because it recognizes greater than 312 as a cardinal. This is also, obviously, this thing has never seen very likely GitHub issues, the model that I'm using, but it's recognizing certain patterns, like even recognizing a unit as a product. So this is interesting. But this, as you can see, is kind of grouping these tokens in a single one that represents an element of code that can have a role in the sentence. So this could be the equivalent of a noun in a foreign language. So after that, more importantly, I'm going to show you dependency parsing. And I'm going to use a module called Spacy. that actually shows the tree in a cool way. These trees can be very long and very complicated. They have a root. In this case, it's this verb. And then you can imagine like a tree where every arrow that points to from the head to a children is actually annotated with some kind of description of what is the dependency that you have between these elements. I'm going to try to find the implicit method. Here it is. And this is actually easy. It's a noun linked to implicit, which is actually linked with a mod. And this a mod is an adjectival modifier. But if you have things like subject or complements of very, very different types, determiners, conjunction, and so on and so forth. If you have a look, actually, this is how it looks like. Nominal subject, root, negation modifier, adjectival complement, and so on and so forth. But I'm interested, again, pretty much in nouns linked to an adjective with an adjectival modifier. And this is my pattern that I'm going to show. So this is the first part. Let's do this analysis of implicit. So I'm going to do pretty much the same imports. I have some domain model classes that actually represent the dimension of an implicit. I'm going to read the issues. I'm going to load the Spacy pipeline, the same as before. And here comes my major Python discomfort. So there's no way, how do you describe a pattern on that tree? There are no types, pretty much, or actually they're very low-level types in the library. You need to describe it as a list of dictionary, where then you have a string as a key, and a union or a string or a dictionary that is actually a row type. It's still probably the union of a string and another dictionary in many cases. So I'm not going to even try to do this ScalaPy. I'm going to use this actually interpolator, pi, that is going to construct this object automatically. I'm going to pass it a piece of Python. I'm going to show you how to improve this later. And this is what I have, pretty much a root node that I'm looking for, implicit, that has this lemma, implicit, is an adjective, and is linked with its add with an adjectival modifier. Then I'm going to look for all the nouns that are linked, that have as a descendant this implicit node, and there are nouns in the post-tagging. The second pattern that I'm going to show is the one where implicit is actually a noun. And that's it. So I'm going to create a matcher as before, and I'm going to actually run it. Okay. So let's extract dimensions. This is the piece of code, the function that I'm going to use. In the meanwhile, I'm going to run it. I'm going to show you a bunch of things. So, you know, in Scala, with .apply, you use it for function invocation and also to access like the element of a list. But in Python, the two things are different. We've seen the call is like to invoke a function or an object that looks like a function. But for bracket access, you have getItem, you know, the corresponding model. So in order to access getItem, you cannot use .apply, otherwise it's going to try to invoke it in Python. You need to use this bracket access, and this is like everywhere. So this is like going to take the resulting of the matching, processing them, and extract dimensions. But this is just very boring code. So this is, by the way, the result of a match. Again, very low-level types. These are actually the indexes of the token that actually match, and I'm going to reconstruct it in this way. By the way, the code will be shared, so don't worry. So these are dimensions calculated. I'm going to show you how many I have. So this is my study. So I have around 100 in all the issues that I have in mentions of implicit methods, 67 mentions of implicit params, and only 23 of implicit classes. And then I have 171 others. And the use of implicit as a noun around 100. So I want to dig into what is these other implicit mentions. Implicit search, implicit scope, implicit resolution, implicit type, implicit function, implicit error, match, and definition, and so on and so forth. But it's kind of a sort of a long tail, not really. So an example of implicit as a noun. Double import of implicits. Yeah, this is actually one case and another in the end. So even if in the dictionary implicit is an adjective, if you use it as a noun, this model is actually going to find it. This is pretty cool. So to show you the last part of this analysis, I've done something that I actually expected. This is like a graph that shows the number of open issues mentioning all implicits, and it's actually increasing over time. So I'm like taking all the issues that mention implicits, and I'm gonna count it over time when they are still open. And more interesting maybe, the proportion. I was surprised because nowadays it's like around 7% of the ones open, okay? But there were two spikes. I don't know if they make sense for what happened in Scala. But around July 2018, there is an increase until May 2019, a huge one, and a huge one in June 2016. I don't know if it makes any sense, but this is like the result I have. So this is like for the first part of doing this. Now I want to go back to the presentation. And what I showed you are like the basics. But obviously, I was using this library really like a dynamic type in Scala. So this is not very idiomatic in Scala. What I want to try to show you is how to minimize your dynamic discomfort or your duck typing discomfort. Okay. And maximizing the comfort of static types. So what I'm going to show you, it's similar to what you had to do in Scala.js before scalably typed, if you know about it. But I'm going to go through slowly. I'm going to use real code in this case, not a notebook. So this code is doing pretty much the same. And here, instead of having to import the module, I actually have an object. I'm going to show you how it looks like. And I'm calling this preferred GPU method, which is the same as before, but now I have a syntax with types, right? And the same happens when I call load. Now I have some type. Actually, it's returning some Spacy language. Then there is something more magic happening. But even for the dependency matcher, I have done something that actually creates types. And this is way more readable. For example, for NLP, yes, I can call a dot apply like before, but the extract mention is also going to use, let me see if I can open it. Yes, it's going to use it actually, the dot apply as a bracket, bracket access actually in Python. So what I'm doing is what also in Scala.js was done with facades. This is very good. It's using a combination of macros and annotations, but not annotation macros, as far as I remember. So what happens here is that you can have an object, in this case, the object Spacy, that extends a py.static module Spacy. And this is my object that reifies the access to a Python module. And now you can have, methods that are present in the Spacy module, in particular load or preferred GPU. You can rename them. So if you don't need to rename them because either you like snake case or because you don't need to because it's just a word, then you can just have the signature and you give py.native as an assignment. This is a macro that is going to do automatically the call to the dynamic method that then will generate the actual method call for this specific load method. But if you want to rename it, then obviously you need to do this manually. So I can call prefer_GPU and convert it, cast it automatically to Boolean. Otherwise, the macro is going to do this conversion automatically. So for things that are more complicated, for example, for a constructor, you cannot do that automatically. You need to create, a fake object in this case, and then an apply method. So this is going to be equivalent to the constructor of this dependency matcher. And here, being a little lazy, I didn't want to model and construct a type for this parameter, but you can be gradual as much as you want. And then, obviously, I'm going to manually call the constructor for the dependency match. So the rest is pretty much OK. This is just showing the syntax sugar for underscore underscore call. I'm going to show you something a little more interesting for the pi bracket access. So I told you that I'm in Scala, I want to use it idiomatic in Scala. And in this case, this apply method in span, but it's the same in Spacy doc. You can access the token by index. And you want to use in Scala, as in Scala, you should apply. So with this annotation at pi bracket access, this is the way you're going to actually automatically convert instead of to a call to underscore underscore call to a call to underscore underscore get item. And so you can use it in a more idiomatic Scala way. Finally, I think I've done pretty much most of it. Finally, I want to show you this particular example. Here, instead of having a normal type, this is the add method that in the dependency matcher is going to add actually a specific pattern. And now I have a class that is not actually a Python class. It's actually my very complicated DSL. I'm not going to go through it now. But pretty much I'm constructing something out of it. I'm going to convert it to actually a Python value, but I'm going to use a custom DSL for this. Why? Because you remember that object with the list, and dictionaries, to use in practice is actually very, very difficult. So since I like DSLs, I try to actually do something a little more elegant, and this is the DSL that I've done. So it's going to use Scala 3 functionalities, in particular one, that I found it very elegant. So now I want to describe the same thing, but with a different format. This different format is the following. So I'm going to have a root token. This is this implicit token. And I'm going to say, OK, with these attributes that I put on a list. And I use this comma equal operator that is going to force the values bound to a particular attribute of the token to be a specific type. So that here I cannot put a string. When I need the post, I need to put an actual post tag. In Python, this would be all strings, so I could tell stories of bugs, and obviously after you run the pipeline for hours, discovering a bug like that, it's very, very annoying. And even in tests, yes, you can try to capture them, but if these patterns are very complicated, it's going to be very annoying. But now I have a DSL that's actually going to do it properly. So how did I implement it? So I implemented actually by modeling, post tags. So a tag could be noun, verb, or adjective, or something more. Or I have dependency tags like a mod, subject, or something else. So what I'm going to do, this method actually is defined in the enum token attribute. So in this case, it's a part-of-speech attribute, for example. And it's going to take as a parameter a type lambda. So a lambda that actually takes a type and gives me another type, so that I can bind the specific type that I want as a value. So in this case, this .type means the specific type of the case of the enum. And this is the type lambda. So if I get, so this is like a way to do it. This is the syntax I prefer for type lambdas, but there is another one, the one with the equal and double arrow. And I'm going to match this type. So if it's a post attribute, then I'm going to force this type to be a post tag. If it's a dependency parsing attribute, then I'm going to force it to be a dependency parsing tag. There are other things like this punct, which is just a Boolean. Or in most of the other cases, it's just strings, like for the case of lemma, or for the case, for example, of the text, if you want to mention the text and so on. And the other thing that I've done is a little abuse of operators at the end that are going to take a pattern and add the dependent node like I was showing before. So this, for example, less than is like compatible with the kind of pattern that you have in Spacy that represents, okay, if A is less than B, it means that A is a descendant of a node B at one step. This is the opposite, this means the head. This is like descendant at any level, and this is head at any level, so any parent at any level. So in the end, I kind of minimized my discomfort by having, not in the basic facade, no here, by having a DSL that allows me to express this pattern in a way more elegant way. And I have both of them. There are real Scala objects. They get translated to Python, but pretty much they are as much Scala as you would like, except maybe if you don't like DSLs, you can use simple case classes and compose them normally. So, yeah. So the rest is pretty much okay. There are other parts like this that probably would require some modeling, again, but in order to show things in an either more elegant way. So, in the end, the person that has done ScalaPy has tried to do something quite cool, which is the following one. So, in principle, in Python, you really have type annotations, right? So you could, in principle, take this type annotation and generate these facades automatically. What is the problem? That these are quite complicated, and like you've seen the type that I showed you before for these objects. So imagine you want to do the equivalent in Scala, you would probably prefer to leave that as dynamic and have no types. So there is actually a generator for facades, but unfortunately, this is like in the middle, like in a sort of limbo, because unfortunately, the project is in a limbo status, if you want. So one of the problems is that people were quite excited, and actually am still quite excited about what this project has done, because actually would allow me to really minimize the usage of certain Python libraries exactly for the things that I need. But unfortunately, this was done by a PhD student, so, you know, when a PhD student moves on, obviously you need someone that actually maintains it. So try it if you like it. I think this would be a great addition to the ecosystem. I have a bunch of suggestions on certain parts, especially it would be extremely cool to take the automatic generation of facades and arrive at the status like the one that Scalably type has done for TypeScript types. So I have 1 minute. I want to show you just one thing. So the cool thing that you can do once you have Scala and all the ecosystem with you is actually even automate certain tasks that you would do with the script. And in particular, one of the things that, for example, you can do with Spacy is downloading the models. This is something that I always forget the first time I create an environment. You need to download certain models, and now I have scripted this as a task in SBT, so that I can put a dependency, and for example, and ensure that that this is being run before actually, for example, executing anything. Otherwise, this would completely crash. So instead of a script, you can have an SBT task. And finally, this is so cool that there are, for example, plugins for SBT that are going to automatically derive according to where you say your environment is and the Python location is, automatically derive the location of the dynamic libraries in Python that ScalaPy needs actually to retrieve in order to run properly. And this is like a classic task that derives the Java ops for ScalaPy, and maybe they look mostly like this. like JNA library.path, and like ScalaPy.python program name. These are done automatically. So this is pretty much it. 7 seconds. So thank you very much. I'm Andrea Mocci. The code is there. I'm gonna add a little more documentation to run it properly, but the code is there. It's on GitLab. Otherwise, on Twitter down there, I will probably post something about it in the next days. Thank you very much. I hope you like it.
Thank you.